sklearnutilsparalleldelayed. Description: the delayed function from scikit-learn's parallel utilities is a powerful tool for parallelizing tasks within your machine learning workflows. It allows you to wrap any function with the delayed decorator, which effectively creates a task that can be executed concurrently. This is particularly useful when you have computationally expensive operations that can be executed independently. Inputs: function: the function you want to parallelize. This function can take any number of arguments. Arguments: any arguments required by the function you are wrapping. You can pass a single argument or a list of arguments. Outputs: delayed object: this object encapsulates the function and its arguments, ready to be executed in parallel. Steps: wrap your function. Use the delayed decorator to wrap the function you want to execute in parallel. Create a parallel execution environment. This is done using parallel from joblib. Execute tasks: pass the list of delayed objects to the parallel instance, which will manage their execution in parallel. Metrics: execution time: you can track the time it takes to execute the tasks with and without parallelization. Speed up the ratio of execution time without parallelization to execution time with parallelization. Visualization plots: Gantt chart: this can visually represent the scheduling and execution of tasks in parallel. Fine-tune parameters: number of jobs determines the number of parallel processes. Backend controls the parallelization mechanism, e.g., threading or multiprocessing. Verbose controls the amount of output during execution. Uncertainty methods: not directly applicable. Delayed is a parallelization tool, not a method for uncertainty quantification. Challenges and fixes. Challenge 1: memory limitations when dealing with large datasets or complex computations. Parallelizing tasks can lead to memory issues if the processes consume excessive amounts of memory. Sample use case that resulted in challenge 1: processing a massive dataset with a memory-intensive function. Fixes to challenge 1: reduce memory usage in the function, optimize the function to minimize memory footprint. Increase system memory if possible. Upgrade the system's memory capacity. Chunk the data, process the data in smaller batches to reduce memory demands. Challenge 2: GIL limitations in Python. The global interpreter lock GIL limits the true parallelism of threads. While delayed can be used with the threading backend, the GIL may limit its effectiveness, especially for CPU-bound tasks. Sample use case that resulted in challenge 2: performing computationally intensive operations with threading. Fixes to challenge 2: use multiprocessing backend if your tasks are CPU-bound. Switch to the multiprocessing backend to leverage multiple cores. Consider alternative languages if true parallelism is crucial and Python's GIL is a constraint. Consider languages like C or Java that are less affected by the GIL.